Hello, everybody. I'm Daniel Brandenburg. This is for Fundamentals of Aerodynamics. This is Project 2. So let's go and get this started. Hopefully you guys can see my screen. All right, so I already have the project set up and complete, so I'm going to walk you guys through what I did. This is the geometry. So it has a height of 4 millimeters and a length of 600 millimeters. All you have to do is create your sketch, make sure that's in millimeters, and then go to concept, surface from sketches. You'll select your sketch, apply the geometry, and you'll be good. Then you go over to your mesh, which is right here. All right. So from here, you're going to want to add your mesh. It's going to just have this. You're going to want to hit right click. Hopefully, there you go. Insert. You're going to insert two sizings and then one face meshing. So you're going to start off with your first sizing. What you want to do is select your top and bottom. So how you're going to do that is go up here, edge, select, control, select. It's going to have you say like apply geometry. You're just going to apply your geometry. It's going to have, I want to say element size. You're going to change that to number of divisions. Select however many divisions you want. I have 600. That seemed like a pretty good number when I used it. Uh, Capture curvature. I believe this will be set to yes. You're going to want to change that to no because yep. So capture curvature, nope. And it's going to say soft, change it to hard. And then for your second edge sizing, you're going to select your inlet and then your outlet over here. And it's going to be the same thing. Number of divisions. I picked 100 for this. Capture curvature, no. And then for your behavior, hard. And for your face meshing, you're going to select your face. It's going to have, I want to say it's going to have quadrilaterals. Don't have it as triangles. I have it as quad. Believe that's it for the mesh. You're going to generate that. And then you're going to go to you're going to have to create your name selections. And I need to update my mesh real quickly. Nope. There we go. And you can see here, all that. Name selections, you're going to have your walls. They're not going to be in the same selection. So you're going to, with your edge tool, select that, the top wall, and you're going to want to name that. And you're going to want to name each one of your walls. So top wall, bottom wall, outlet, and inlet. And that's going to be it for your mesh. After that, you're going to go to your setup. When it comes up with your prompt for setup, I have it as double precision and then 2 for the solvers. It's gonna prompt you here. Ignore this right now, but leave this here, pressure-based, absolute, planar, and steady. Go to models, where it says viscous, it's gonna have it somewhere down here. I want to say one of these K epsilon or K omega. You're going to change it to laminar. Select OK. Go to your materials. To make sure that the Reynolds number is right, what I did is set my density to 1 and then viscosity to 0.0001. That worked for me. I think you make it like 0.001 if you want. I think it'll still work. And then for your boundary conditions, inlet, it's going to want to add one, I think. Okay, here we go. Yeah. Velocity magnitude is going to be 5 meters per second. We get this from, let me get this up. Here we go. Incoming velocity is 5 meters per second. Outlet. I've seen some people talk about whether or not some people do prevent reverse flow. For me, they both kind of end up the same. So if you want to use it, be my guest. For the wall, bottom wall, it's going to be moving at -2 meters per second. So to the left. There you go. It's going to start off at stationary. You're going to move, select moving. Don't mess with this. Make sure it's translational. For your direction, it's going to be -1, and then for your speed, it's going to be 2. And then go to top wall. It's going 3 meters per second, positive, moving, translational, easy. I believe that's it for your setup. Yep. So you're going to want to initialize. Run your calculation. Make sure your iterations are high enough. That's because I messed with the mesh earlier. All right. There we go. Okay. Perfect. All right. After everything's done, what are we being asked to do? I think we're asked to do velocity contours with the vectors, show pressure contours, and the profiles. Okay. So just to make it easy, we're going to start off with our pressure. You're going to create your 3 pressure. So dynamic, total, static. Pressure, static. Bottom wall, inlet. Select your 4 walls and then your interior surface body. Save and display. So our dynamic. So when you zoom in, you're going to see this. Something like this, depending on what you have. But yeah. Here. Total pressure. You're not going to see that much of a change until you get later on into it. You're going to start seeing that's more red, the outside's more orange, and that's going to continue for your entire body. And yeah, I assume you probably get the point. Static pressure. It's very uniform when it comes to the change. Just progressively going down to blue. And then your velocity, save and display. Zoom out. It's going to be a lot like your dynamic pressure, where you have this boundary layer here. And then it reaches a certain height and it just kind of stays there on the bottom and top. You then have to create your velocity vector. So you name that velocity, velocity magnitude. Select these here. I'll let you guys know what mid and end means later. And there's our not contours, vectors. You can see it's going left here and then goes to 0 and then to the right, kind of with that boundary layer. And so, as it says here, velocity contours with the vectors. So what you're going to do, you're going to create a scene. It's going to have your name. We're going to have these. I'm actually just going to go select the one that we have. Select your velocity and velocity vector. Let me show you guys what this is first. You have your vectors, and then it'll add the color from your contour. And depending on how high you have the transparency here, kind of changes how it looks. However you like it, whichever one you think gets the point across, then it's good. And then plots. Done with that one. All right. So for your end and midpoints, to create these two lines, you're going to hit new line. You're going to name it. For mine, for your midpoint, it's going to be halfway through your body. So since it's 600 millimeters, it's going to be 0.3 right here and 0.3 here. This is going to be 0, and then this is going to be 4 millimeters by meters, of course. You're going to create your line. You're going to rename it to end, and then you're going to go to the end for your X. So 0.6, 0.6, create, and you're good. How it's going to start is going to have position on the X-axis. This is your X is going to be 1, your Y is going to be 0. Deselect position on X-axis, select position on Y-axis, move that to 1, move that to 0. Right? No, move this to 0. Move this to 1 as it is now. X-axis function, that's going to be your velocity. And if we run this, this is what we get. This is not what we want because it has this like kind of goes back up here. So you want to go to your X velocity, save plot. There you go. Now you have it. So that where does that take us? That takes us up to show velocity profiles. So that's C for D to get the max velocity and then where it occurs. You're going to want to go down to somewhere. Here we go. Reports. Surface integral. You're going to want to select your end and mid. Find your vertex maximum. Velocity. X velocity. Compute. It's going to give you 7.47871. And what you're going to do is not zoom out, zoom in to here. And that's fairly close, 7.48. Yeah, that's close enough here. And it's saying that it's at about a height of 2.36, sometimes it's 2.37 millimeters. And so that's where your max height is, or max velocity, and where it is on the profile in terms of height. And then one more thing you're going to do, this is for part E. Go to surface integral. Instead of vertex maximum, you're going to do area weighted average. Instead of velocity, you're going to go to pressure, static pressure. Compute. Down here, you're going to see end and mid. This is in pascals. You're going to go ahead and write this down, and I'll show you where that comes up, where we're going to use this. So let's make sure we got everything. Went over that. Went over the pressure contours, profile, max velocity and height, and then determine the pressure gradient. All right. So this is where I have all my stuff. Mark out down everything. What you're going to want to do is use your simplified Navier-Stokes equation here. Integrate it twice. You get your x velocity function. Using your boundary conditions to solve for conditions 1 and 2. Integrate, plug it in to this. So where your average velocity in the x direction, plug in u of y. You get this final equation. plugging in what we have. So our height is 4 millimeters, our viscosity is here, and then our U average is 5 meters per second. We get that because the inlet velocity is 5 meters per second, and because it's steady state or it's a steady flow, the exit has to be 5 meters per second. So the average is about 5 meters per second. Plugging that in, we'll solve for it. We'll get the theoretical pressure gradient to be 337.5 pascals per meter. And then this is where we use these numbers. dP dx is also the change in P over the change in X. Our change in X is 0.3 meters, and our change in P is here. Using that, we get 335.681 pascals per meters. Percent error, plug it in, you get a percent error of about 0.539%, which is very good, I think, because it's less than 5% error. But yeah, I think that's it for the project. Went over that. Everything else is good. Yeah, your answer will change depending on whether or not you have the same boundary conditions or dimensions. But yeah, that's it.